Just 4 light-years from Earth lies a planet that has captured the imagination of scientists and space enthusiasts alike. It's called Proxima Centauri b, and it's the closest exoplanet ever discovered. Some even believe it might be the first place beyond our solar system where we detect signs of alien life. That alone makes it one of the most important targets in our cosmic neighborhood. And who better to explore it than our brave, slightly unlucky interstellar traveler, Chase? He's already been to several exoplanets, and yes, he's also died on each one. But this time things feel different. This time there's hope. Despite his less-than-perfect track record, Chase is convinced that Proxima Centauri b is the one that'll finally work out. It's so close he jokes he could DoorDash his favorite tuna pizza and have it delivered fresh, well, relatively speaking. The system is even moving closer to Earth, so in about 30,000 years, it'll be just 3 light-years away. That's practically our cosmic backyard. Unfortunately, after that window of closeness, Proxima Centauri b will drift farther away again. Eventually, Andromedae will take its place as the nearest star to Earth, besides our Sun, of course. But Andromedae doesn't even have any known planets. That kind of cosmic shift is a bit of a bummer. But even though Proxima Centauri b is in the nearest star system to us, it's still a massive journey away. If we launched a spacecraft from Earth today, it would take roughly 165,000 years to reach the Alpha Centauri system. So even our fastest probes are in no hurry to get there. But imagine standing near the edge of that system. You'd be able to see all 3 stars, Alpha Centauri A, Alpha Centauri b, and of course Proxima Centauri. It's a beautiful and complex dance of stellar bodies, all bound together by gravity. Within this triple star system, Proxima Centauri b orbits its namesake star, Proxima Centauri. This little red dwarf orbits far from its brighter siblings, Alpha Centauri A and B, which are tightly locked in a binary system. Together, they form one of the most intriguing star systems in our galactic neighborhood. Their gravitational bond is strong, keeping them tied to each other across vast distances. It's kind of like a weird friendship dynamic, 2 best friends and then a third one awkwardly hanging around the outskirts. Proxima Centauri plays that distant but essential third role in this cosmic trio. Chase is ready to land and start his adventure. He's pumped. Proxima Centauri b orbits right in its star's habitable zone, the region where temperatures might allow liquid water to exist. That sounds great, right? But there's a catch. Just being in the habitable zone doesn't automatically make a planet habitable. The zone is just a basic temperature guideline, not a promise of Earth-like conditions. And Chase, ever the optimist despite his death record, thinks it still has a shot. He's not entirely wrong. Habitable zones are just one piece of the puzzle. A lot depends on the atmosphere, radiation, and surface conditions. Proxima Centauri itself is a red dwarf star. It's nothing like our Sun. It's smaller, cooler, and much dimmer, but that doesn't mean it's less important. In fact, it burns through its hydrogen fuel much more slowly than the Sun. While our Sun might go red giant and die out in 5 billion years, Proxima Centauri will still be glowing steadily for trillions of years. That means planets orbiting this star have a far longer potential window for life to evolve. Chase jokes that when the Sun explodes and wipes out all life on Earth, he'll still be chillin' up here for trillions more. But Proxima Centauri comes with some serious downsides. Since its star is so dim, emitting only about 0.1% of the Sun's brightness, the planet has to orbit very close to get enough energy. That tight orbit creates problems. One big issue? Radiation. Red dwarfs are notorious for violent solar flares, sudden, powerful eruptions of radiation. These bursts can be deadly. They bombard planets with extreme UV radiation and charged particles. Over time, these repeated blasts could completely strip away the planet's atmosphere, making it incredibly difficult for life to take hold or survive. Chase, as usual, is not thrilled to hear this part. The flares from Proxima Centauri can be devastating. High-energy UV radiation from the star ionizes particles in the planet's atmosphere. This process rips electrons from their atoms, and when enough electrons escape into space, they drag positive ions along with them. The result? The atmosphere gets slowly peeled away layer by layer. What remains is a nearly airless world, with only trace amounts of carbon dioxide, methane, and nitrogen left. When Chase asks his robotic assistant Rico for an atmospheric scan, the result is pretty disheartening. The planet's atmosphere is thin, way too thin to offer any real protection from radiation. Still, Chase isn't ready to give up. He's determined to explore the planet and see if there's any place he can set up shelter. Maybe even find some water. Maybe, just maybe, Proxima Centauri still has something to offer. But there's another twist. The planet is tidally locked. That means the same side always faces the star, while the other side is trapped in eternal darkness. One half of the planet is in permanent daylight, possibly scorched and dried out. The other half is a frozen, shadowy wasteland. Chase jokes about having to choose between endless sunburns or never-ending seasonal depression. The concept of a tidally locked planet makes things complicated. Without a rotating day-night cycle, the climate becomes extreme, scorching on one side, frozen on the other. But there's a narrow region that might be just right. It's called the Terminator Zone, the strip of land between the hot side and the cold side. This twilight belt receives just enough light to avoid freezing but not so much that it burns. It might be the only spot on the whole planet that has stable temperatures and even a chance at retaining water. That's where Chase decides to set up camp. The Terminator Zone doesn't move like it does on Earth. It's permanently fixed in place, offering a stable region of mild temperatures. On Earth, this twilight zone stretches about 60 kilometers wide. On Proxima Centauri b, with its thin atmosphere, it would be a little narrower, but still enough space to build a shelter. Chase gets to work, determined to make everything radiation-proof. With the levels of UV blasting from the sky, he knows he'll have to insulate every wall. It's exhausting work, but if he can survive here, maybe there's still hope that life, any life, could survive too. As Chase finishes sealing his shelter, he finally has time to explore more of Proxima Centauri b's surface. He scans the land for any signs of liquid water, because where there's water, there might be life. And remarkably, near the Terminator Zone, he finds trace signs of subsurface ice. Not much, but just enough to suggest that water might once have existed here in liquid form. Perhaps there were ancient lakes or oceans before the atmosphere thinned. Maybe those oceans dried up under relentless radiation. Or maybe, somewhere below the surface, a bit of that water still lingers, hidden in underground pockets. That little discovery gives Chase hope. If water still exists beneath the planet's crust, it could offer protection from radiation and a stable environment, perfect for microbial life. Life doesn't need to look like us to survive. On Earth, organisms thrive in the most extreme conditions: boiling hydrothermal vents, frozen tundras, and deep underground. Could something similar exist here? Proxima Centauri b might be hostile on the surface, but underneath, life could still find a way. Chase thinks of extremophiles, those tough little life forms on Earth that eat sulfur or survive acid baths, and wonders what kind of alien cousins they might have out here. Back on Earth, scientists have been analyzing Proxima Centauri b's potential for life using data from telescopes like Hubble, Chandra, and now the James Webb Space Telescope. But from 4.24 light-years away, it's hard to get detailed answers. Most of what we know about this planet comes from observing how its gravity tugs on its star. That's how we figured out its mass and orbital distance. But we can't yet see its surface clearly. Not even James Webb has enough resolution to give us a high-def image of Proxima b. All we get are hints, indirect evidence, and lots of theories. Still, James Webb is doing something amazing. It's capturing the light that filters through exoplanet atmospheres as they pass in front of their stars. This technique, called transmission spectroscopy, lets us decode the chemicals in those atmospheres, gases like oxygen, methane, carbon dioxide, and more. If we see those in the right balance, it could be a huge clue that life is present. Unfortunately, because Proxima Centauri b's orbit isn't perfectly aligned from our view, it doesn't transit its star from Earth's perspective. That means we can't use this powerful technique on it directly, at least not yet. Despite this setback, astronomers haven't given up. There's even talk about sending tiny spacecraft to the Alpha Centauri system. One ambitious proposal is the Breakthrough Starshot project. The idea? Launch miniature spacecraft, just a few grams in weight, powered by Earth-based lasers. These little light sails could reach 20% the speed of light, meaning they could arrive at Proxima Centauri b in about 20 years. The catch? They can't slow down once they get there. They'd simply fly past the system, snapping pictures and gathering data in a quick, one-shot pass. It's a bold plan, and one of the best chances we have to see Proxima up close. Even if we did send spacecraft to Proxima Centauri b, it would take decades to plan, build, and launch such a mission. And even then, there's no guarantee we'd find life. The planet might be completely sterile. Or maybe it once had life, but lost it due to solar flares and radiation. That possibility weighs heavily on scientists. It's a sobering reminder that even a planet in the habitable zone isn't guaranteed to be habitable. Just because a planet can support life doesn't mean it will. Nature is harsh. Evolution is brutal. And the cosmos doesn't always play fair. Yet Proxima Centauri b still represents a monumental opportunity. It forces us to ask deep questions. about life, survival, and the future of humanity. Could we live on a planet with such extreme conditions? Could we terraform it or build underground cities shielded from radiation? Maybe someday, if technology advances far enough, we'll make that leap. But until then, Chase's journey is purely imaginary, a reflection of our dreams, our fears, and our relentless drive to explore. He stands in his shelter, gazing at the red glow of Proxima Centauri in the sky, wondering if anyone, or anything, is out there watching back. He picks up a handful of the dusty soil, running it through his fingers. It's cold, dry, lifeless. But something about the place feels ancient. Like it has secrets buried beneath the surface, waiting to be uncovered. Rico reports some strange readings a few meters underground. Maybe a magnetic anomaly. Maybe just leftover radiation from a flare. But Chase can't shake the feeling that something more is down there. Not necessarily life, but maybe evidence of something that once lived. A fossil. A chemical trace. A hint that Proxima Centauri b wasn't always this barren and bleak. Even if life never existed here, Proxima Centauri b teaches us valuable lessons. It shows us what can go wrong. A planet too close to its star, blasted by radiation, stripped of its atmosphere and frozen in a tidal lock. It reminds us of how fragile our own Earth is, and how lucky we are to have such a balanced environment. Every world we discover, even the inhospitable ones, helps us understand our place in the universe a little better. They're like cosmic cautionary tales. They warn us about the dangers of climate collapse, magnetic field loss, or unchecked solar activity. But they also inspire us. They push us to build better telescopes, faster spacecraft, and smarter systems. They spark curiosity in young scientists and bold visionaries. Proxima Centauri b may not be a paradise, but it's a beginning. The first step in our journey to explore nearby stars. One day, when we finally set foot on another world, this planet will be remembered as the one that started it all. A symbol of both warning and wonder. Chase knows this. And even though he's cold, tired, and slightly irradiated, he's proud to have made it this far, even if only in our imagination. So, as he gazes up at the dim red star that gives this world its name, Chase takes one last look around. He didn't find alien cities or lush jungles. He didn't even find breathable air. But he found something just as valuable, the will to keep going. To keep searching. To believe that somewhere out there in the stars, another world is waiting. One that will welcome us not with fire and radiation, but with open skies and living oceans. And maybe, just maybe, that world is a little closer than we think.